Hello, everyone. I hope everyone's doing well. And we're going to start off by looking at some data. So let us take a look. And we're going to have some boiling points. Here we go. First substance, hydrogen iodide, HI, has a boiling point of negative 35.3 degrees Celsius. And then we're going to be going up group 17. So right above I is Br, so H, Br, negative 66.0 degrees Celsius. Keep on going. HCl has a boiling point of negative 85.1 degrees Celsius. So you can see we're going down, 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 down. But here's the weird thing. HF has a boiling point of 67.1 degrees Celsius. How weird is that? Right? Super weird. Odd man out. Why the heck is hydrogen fluoride's boiling point so high? And that has to do with hydrogen. Hydrogen is a very small atom, very small radius, and has a very small electronegativity. And we remember that the dipole-dipole intermolecular force of attraction has everything to do with the fact that molecules are polar. And obviously, a more polar molecule makes a stronger dipole-dipole. Well, if hydrogen is so small, it can have a or make a really polar molecule. And in fact, what happens is in this HF molecule, this is like a superpolar molecule. Right? And because it's so polar, in fact, it's almost ionic. Right? H is group 1. It's almost a metal. H is not a metal, but it's almost a metal. It's almost ionic. Because it's so polar, we actually make a special form of dipole-dipole. And this special form is called hydrogen bonding. Now, this is super confusing because, number one, I'm going to write this in big, obnoxious letters, not a type of bond. It is not a chemical bond, which is super confusing. Hydrogen bonding, what hydrogen bonding is, it's a uber, and I think you actually put 2 dots over the U, uber strong dipole intermolecular force of attraction. Super duper strong that it actually gets its own name. It's actually a step above. So we would say that HF has hydrogen bonding. And in fact, hydrogen bonding, we say that hydrogen bonding is fine. What does that mean? This is how you can tell whenever a molecule has hydrogen bonding. If a hydrogen atom is bonded to either a fluorine, oxygen, or nitrogen atom, the resulting molecule will exhibit hydrogen bonding IMF. Super strong, which means that substances with hydrogen bonding if they're super strong, they're going to have high melting points and high boiling points. And in fact, if we look at the water molecule, here's the cool thing. You know what? I'm going to do this on a new page. Here's what's so cool about what one of the many cool things about water. That we can actually make, ready for this? One let's see if I come on. I know you can do it. Good. 2, 3, and 4 hydrogen bonds. And I will draw them in purple to show you. 1, 2, 3, and 4. In fact, water makes 4 hydrogen bonds, or hydrogen bonding IMFs. Each water molecule makes 4 hydrogen bonding IMFs with other water molecules around it in a solid. And this actually gives water such interesting properties. This is the reason that we are alive. This is the reason that water freezes at 0 degrees Celsius and not way below 0. And that's good, because if hydrogen bonding didn't exist, we would all be dead. Okay, let's do a practice problem. So let's look at 4 different molecules. Molecule number 1, chemical formula COC. I'm sorry, C2H1, 2, 3, 4, 5, 6, H6O. O to C, H, 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 and H. That's number 1. Number 2, H2O. Number 3, and F3. F, F. And the 4th one will be, is it C7? C8, actually. C8. Oh, not C8. That's C3H8O. Which, C to C to C. H is here. H, 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 O, H, H, H. So then my question to you is, starting with, which of these molecules, if any, will exhibit hydrogen bonding? Okay. And we can see here, and the correct answer is that 2 of them, and only 2 of them, will exhibit hydrogen bonding, right? Everything here has the required element. That's not true. Everything here has either oxygen, nitrogen, or fluorine in it. Let's look at the individual ones over here. This molecule, it has oxygen and hydrogen, but this oxygen is not bonded to the hydrogen. So the reason that this molecule doesn't exhibit it, there is no H bonded to the O. So there's no hydrogen bonding, or this molecule will not exhibit hydrogen bonding. H2O, we just talked about H2O and how it exhibits hydrogen bonding. So that's a check. Check. Down here, it has nitrogen and fluorine, but there's no hydrogen. No H. So no hydrogen bonding. And over here, this will have hydrogen bonding. Check. So we have to be careful that just because you either have nitrogen or fluorine, or even if you have oxygen and hydrogen in a compound, doesn't mean you're going to have hydrogen bonding. Only these 2 will exhibit hydrogen bonding. Okay? And that is your little lesson about hydrogen bonding for tonight. I hope everyone has a good rest of your night. Bye.